everyone, it's Actuary Dude here again with another question. So, let's get to it. The force of interest, delta t, is a function of time at any time t, measured in years, is given by all of that. So derive and simplify as far as possible expressions for Vt, where Vt is the present value of a unit sum of money due at time t. Okay, so let's start writing down something over here, and let's find out what V of t is. So to start with, we have e to the negative integral of 0.04 plus 0.01 t between time t, because that's what we're trying to find, from 0. Okay, so in order to find this, we find the integral of this bit over here, which is 0.04 t plus 0.005 t squared, because that's t squared, and then 0.01 divided by 2. So that's that bit over there. We still have the negative on the outside. I haven't forgotten about that, and that goes between t and 0, and it's e to the power of all of that. So now we can just sub in t into all of that, which is going to be itself, and then minus 0 subbed into the t values, which is just 0. So it's really just this multiplied by the negative. So that's going to be e to the negative 0.04 t minus 0.005 t squared. Okay, so it looks pretty good, and that's for when z is less than or equal to t, which is less than or equal to 10. Okay, so that's good. Now the next bit is the 0.05 bit, but firstly we've actually also got to find v of 10, and then we've got to multiply it by what we've got for whenever t is greater than 10. So v of 10 is equal to e to the negative 0.4, because that's 0.04 times 10, minus, and that's going to be 0.005 times 100, which will then be 0.5, which is e to the negative 0.9. Okay, so that's v of 10. We'll remember that for later. And now we just have to find e to the negative integral between time 10 and time t of 0.05. We can say dt over there, which I didn't write on the other one, which doesn't really matter too much in this case. So over here we've got this, the integral of 0.05 is 0.05t, and that's still there. We have the negative on the outside, and that's between t and 10, and that's e to the power of it. And then, so when we sub that in, it's going to be e to the negative 0.05t, and then it's going to be minus this minus over here. I've already started adding, so it'll be a plus 0.05 times 10, which is 0.5. That's a positive, and then we just have to multiply it by our v of 10, which is e to the negative 0.9, to give us what v of t will be when t is greater than 10. So that is, over here, e to the negative 0.05t, and that's plus 0.5 minus 0.9, which will then be minus 0.4 for when t is greater than 10. Okay, so that's the answer to part I. Now let's look at part double I. I'll just note that there, that was part I. Part double I has got A, so calculate the present value of £1,000 due at the end of 15 years. Well, all we've got to do is take this £1,000 and discount it back 15 years. So we'll multiply it by our discount rate when t is equal to 15. And all we have to do is sub 15 into this bit for when t is greater than 10, because t is now 15. So let's use Excel to solve that bit. And I'll just say that is 1,000 multiplied by the exponential of negative 0.05 times 15 minus 0.4 equals that, 316.64 pounds. Alright, so let's note that down. 316.64 pounds. So that's the answer to double IA. Double IB says calculate the annual effective rate of discount implied by the transaction. So what rate can we use to get from 1,000 to this bit over here? That's an annual effective rate. Well, as we've seen in another video where I kind of did sort of inverse from an interest rate, that would then be 1,000 multiplied by 1 minus d, and it's not convertible anything, it's just the annual effective, multiplied by 15 years, to the power of 15 years, should give us the 1,000. So that means d is going to, sorry, that's not 1,000, that is 316.64. So in order to find d, it's going to be 316.64 divided by 1,000 to the power of 1 on 15 to get rid of that, and then 1 minus that whole answer should tell us what it is. So let's just work that out. Equals 316 divided by 1,000, close brackets, to the power of 1 on 15 equals whatever that is, and then 1 minus that will give us D, 0.0738, which is 7.38%. 7.38% per annum. And there you go, that's the answer to part B, double I. And now we can look at triple I. So a continuous payment stream is received at a rate of 20 e to the negative 0.01 t units per annum between t equals 0 and t equals 15. Calculate the present value of the payment stream. So how do we find that? Well, the present value is equal to the integral between the time frame given, 10 to 15 years, multiplied by a rho of t, and in this case, rho of t is 20 e to the negative 0.01 t, 20 e to the negative 0.01 t, and that's multiplied by v of t. So v of t in this case is this bit over here when t is greater than 10, so 10 to 15. So it is e to the negative 0.05 t minus 0.4. And I should just continue that, separate that, and there can be a dt written over there. So all we've got to do is find the integral of this and we've got our answer. So I can take out 20 to make life easier, put it between 15 and 10 still. Simplify this, so e to the negative 0.01 t multiplied by this bit over here, that's going to be e to the negative 0.06 t minus 0.4 dt. And the integral of this is the function divided by its derivative of the index. So that's then going to be 20 divided by, that'll be negative 0.06. And I can actually take that out of the whole thing and make that between 0.06 t minus 0.4. And that's from 15 to 10. So that would all be divided by negative 0.06, but I can actually take it out because it's got no t's attached to it. And now all I have to do is just do this multiplied by this when you sub in 15 minus this when you sub in 10. And let's use Excel to find that answer. So I'll just bring it a little closer so we can see it's going to be 20 divided by negative 0.06. Yep, that's it. Multiplied by the exponential of negative 0.06 times 15 minus 0.4, and then minus the exponential again of negative 0.06 times 10 minus 0.4, and close the brackets for all of that, and that is equal to 31.78, and that's the answer. So 31.78 pounds, dollars, cents, whatever it's talking about there. So do we find that? That was the present value of the payment stream. So all I can say now is thanks so much for watching, and comment if you have any questions, please.